Hey guys, this is Patrick from STH. Today, we are going to take a look at Intel's cheat code for future performance. Now, this isn't something that's just a future technology. You can already get it today, and this is an example right here. This is an Intel QuickAssist adapter. Now, QuickAssist is not necessarily a new technology. It's been around, and we've been covering it at STH since I think like 2013. I mean, this thing's been around for almost a decade, and yet it's something that a lot of people still don't know about. So I thought, why don't we go take a look at QuickAssist? Let's explain what it is, let's show what it does, show you the performance benefit that you get from it. But I also want to talk about things like, hey, like what kind of generations are there? A lot of people don't know that. How do you even use it? What are the differences? And even, are there other things that you can use other than QuickAssist technology and get some of the benefits that you get in the hardware accelerators? That sounds like a lot to cover, and so we actually do have a companion article that's going to be going this. You're going to see this in the description. We'll link it there, but that'll have a lot more detail than we're going to be able to go to because, frankly, I don't want to read CLI output to you guys because that's going to be boring, and you guys can all read most likely. But we're going to have all that information in the description. Now, for this video, I actually traveled all the way from Austin, Texas up to Hillsboro, Oregon. And Hillsboro is an absolutely beautiful place, but it's also a major center for Intel and Intel development. I worked with the Intel performance team up there, and they are sponsoring this video because, well, frankly, I had to fly up there and definitely needed some help getting this all put together. But of course, like everything we do, this was not reviewed by Intel prior to going live, nor was the article or anything like that. We get to do everything editorially independently, but I just wanted to show you this, and they said yes, which I think was absolutely awesome and that they would support it. So this is gonna be a really fun video. I'm really excited. Let's go get into it. Okay, so the quick background on this is Intel QuickAssist Technology is often called Intel QAT. And I'm probably gonna call it QAT for most of the rest of this video. And something that a lot of people don't know about QuickAssist is that it is actually something that was brought to market and announced by a I think like executive vice president back then in 2007, this guy named Pat Gelsinger, who just happens to be the CEO now after he did a little stint over at VMware and stuff. The product in 2007 was called Tolopai, and the basic idea was that Intel wanted something that could help accelerate a lot of this like network packet processing and a lot of the things that were becoming emerging workloads. Something you have to remember about those days is that, well, we didn't have fast WAN connections, the same like speeds that we have today. The other thing you have to also remember is the fact that things like HTTPS, that wasn't standard. So things have definitely changed over the years, and so has QuickAssist technology. And the first time that we really encountered QuickAssist was, I think we did like the first review of the Intel Atom C2000 series with Supermicro back in 2013. And the first one that we did was the Avoton series, which was really the compute-focused C2000 series. And then there was a C2000 that ended in 8, and that was the Rangeley product. Now, Rangeley was really revolutionary because that was the product that took the Intel Atom cores, the new out-of-order cores that were really, really good at the time, and then it also layered on the QAT acceleration, so you had things like crypto and compression acceleration with QuickAssist, and put it all into a little package. That product, plus the fact that Intel had a manufacturing process advantage back in 2013, was the kind of key product that really kept ARM out of the data center for a long time. Let's be clear, the Rangeley product was an absolute category killer. And part of that was really this QuickAssist technology. But since the Intel Atom C2000 series, the technology has really become a lot more widely adopted. A couple examples, you can get QuickAssist in things like the Xeon D 1500 series, I think the 1600 series too, but then the 2100 series. You can now get it in the 1700 and 2700 series. Hold that thought for a sec. But you could also get it in the mainstream Xeon server CPUs. An example of that is, well, you used to be able to get it in the platform controller hubs. And then also you can actually get it in card form. And so we're not going to go through all of the different generations here, but we actually do have a resource on the STH main site that we are going to link in the description where we are going to start compiling all of the different generations of Intel QuickAssist with the cards and some of the other models, because the cards were not just made by Intel. There were other companies, that either rebranded or, had their own cards. And so we're also going to go and try putting those all in so everybody can kind of see, at least if you can get an accelerator card, where that goes in the QAT generation hierarchy, plus put links and kind of talk about where the different sets of processors go in that QAT hierarchy. Now, when I say generations, if you don't know QuickAssist, you're probably like, I don't really get it. But the idea is simply that Intel monitors the market and they get customer feedback where they say, hey, customers say, hey, we're going to start using these ciphers more. And then Intel will take those ciphers and actually make them part of the hardware acceleration engines in QuickAssist. What that practically means though is if you have like an old 2013 an Atom C2000 series product sitting out somewhere, you may not have the QuickAssist Acceleration for a newer cipher. So that's why the generations are super important when it comes to QuickAssist, but a lot of people just talk about Intel QAT and they don't talk about generations, but that is a super important concept. So what the heck did we do? Well, I went up to Oregon and we set up a demo in a conference room. And that means that the fact that we had a demo means that we needed a couple things. We needed the system that we were testing. We needed another, kind of server system. We needed, I also wanted to do AMD and Intel, so we needed an EPYC-based system. So we had the Supermicro box there. And then you're gonna see a couple other systems that look a lot like they could hold the, Ice Lake D and other embedded products. We're gonna get to those in a little bit. But yeah, there is going to be a second piece that we're going to have in a couple weeks. And if you're wondering, yes, we do have a complete rat's nest of cables underneath the conference room table here because, well, we did this in the conference room and we needed high-speed networking. So we have things like 100 gig networking here because this is a high-performance accelerator and you need that kind of network speed. So what I want to do today is look at 3 cases that are super common in the industry today. The first one we're going to look at is compression performance, which is very common for storage box makers to use. The second one, of course, is going to be IPsec VPN testing for the folks that do VPN boxes. And third one we're going to look at is the nginx and HTTPS TLS handshake offload, and because that's a huge, just giant application. So those are the 3 things that we're going to look at today. But I also wanted to look at a couple different versions of this, right? Because I wanted to look at not just the hardware acceleration versus kind of like a worst case or just kind of like a super base case. I also wanted to see if there were cases in the middle on these different scenarios. And the reason that these are important is because Intel does actually have a whole bunch of projects out there that you can go find on GitHub, and they really take advantage of a lot of the acceleration that nobody really talks about when it comes to Intel like Ice Lake Xeon CPUs. For example, here are a couple of the new instructions that are in the Ice Lake generation. I think they'll be in Sapphire Rapids as well, but these are these new instructions, and we're gonna actually show you how these new instructions mean that you get a lot more performance out of your just standard Ice Lake Xeon cores, even without getting a QuickAssist adapter. And because I don't really think that's a good idea to have you guys to go type this stuff on GitHub, we're just gonna link these in the main site article that's accompanying this video. So if you wanna go check some of this stuff out, you totally can. It's all on GitHub and you just go click through and go find it. Okay, so for this one, here's the basic test setup that we're gonna use on this. We are going to use the Intel Xeon Gold 6338N, which is the networking based SKU, and we're going to use a dual socket system with that. We're also going to have an Intel QAT accelerator. That QAT accelerator is the Intel QAT 8970, which is the higher performance version of their current generation QAT accelerators. We're also going to use the Intel E810 adapters because we were in the Intel lab and we had access to the Intel adapters, so that's why we're going to use those. They are 100 gigabit Ethernet adapters though, and they're pretty common in the industry, so I just kind of figured, yeah, why don't we just go use those. The other one though that I want to talk about is the AMD system. Here we have a Supermicro 2U Ultra system, and in it we have 2 AMD EPYC 7513 processors. These are also 32 core processors, but I should mention that the AMD processors do run at a little bit higher clocks, and they also have a 200 watt TDP. The Intel CPUs, the Xeon Golds that we're using, only have a 185 watt TDP. The reason for that difference, even though they're 2 processors, so that means that there's a 30 watt TDP total difference between the 2 sets, the real reason that we're using that is because we are going to be having an accelerator and a QAT card in the Intel system, and so because we're going to have that, I figured we should have a little bit lower TDP CPUs there and a little bit higher TDP CPUs on the EPYC side. Okay guys, so the first thing I want to look at is the QAT compression acceleration. This is a huge case for QAT, and I'm going to show you exactly why. Now, the first thing that we did was we took our AMD EPYC and our Intel Xeon Gold systems, and we ran them at 128 cores as our base case, and we just saw 128 threads in their base case. We just saw how much performance do we get. And it turned out that the answer was somewhere in the 9 to say 11 or so gigabits per second range. That's using all 128 threads in both of the systems. That's all we could get. Now, when we layer on the ISA-L acceleration, we got a lot more performance. We had to pick 65 gigabits per second just to kind of normalize because as you'll see, the hardware acceleration numbers, if we would have issues basically at 128 cores just because that'd be way too much data to be pushing through here. But I'm going to just kind of show you that at 65 gigabits per second, you're talking about whether it's the AMD EPYC or you're talking about the Intel Xeon, either one is going to give you somewhere in, say the 30 to 40 cores that are used for this range. And what that practically means is that we're reducing our core count by about 2/3, but we're also getting, we're going from that like 9 to 11 gigabits per second up to 65 gigabits per second. So we're basically getting about 6.5 times as much performance while reducing our use of cores by about 2/3, and that is just in software. Now, something you will notice from this chart is that our AMD EPYC is actually doing pretty darn well in both of these cases because, I tried making this absolutely as fair as I possibly could. And, you see that AMD is actually doing pretty darn well in this particular case when we don't use the hardware accelerator. But the big one, of course, is using the Intel QAT hardware accelerator card, because when we do that, we only need a total of 2 threads to push that 65 gigabits per second. Now guys, compression is absolutely everywhere in modern systems. I mean, it's just used by so many different things. I wanted to show you what this looks like with a hardware accelerator. So let's take a different view of this and let's really look at it on a performance per core basis and look at all of our results. Now, what you're going to see here is that the performance per core on the QAT hardware accelerator card is absolutely just dwarfs everything else. And we got a good jump going from our base case to the IPsec acceleration in our QAT zip. But, frankly, once you get that hardware accelerator, it is much faster. And actually, there's something really cool about this. When we went and looked at it, and you're going to see this in the demo, but let me just kind of show you this. The actual performance that we're getting is a little bit better than we're showing here, because when you look at how much that second thread is, or second core is being used, what you'll see is that it's only being used a pretty darn small amount. I mean, it's running in the say 25-ish% utilization range during the test. So it's really more like maybe 1 1/4 cores is doing this 65 gigabits per second with the hardware accelerator. And that is really the reason that these Intel QAT things are used by so many storage platforms. These accelerators are relatively inexpensive. They're all over the place in everything from the embedded parts all the way up to kind of these cards. And Intel keeps improving this performance over time. So that was absolutely awesome, but let's move to our next one, which is our IPsec VPN testing. Now, for our IPsec VPN testing, what we're gonna do is we're gonna set up like 2,000 tunnels. We're gonna go push traffic as fast as we possibly can through those tunnels. And well, I wanna just kind of show you what the impact of the hardware accelerators are. Now, there are a couple things here that we are gonna do that are a little bit different. And the big one is that we are going to do the best hardware optimization that we possibly can. And this is where some of the instructions that Intel has in their new IPsec processors, where you have things like vectorized AES, that's something that we are gonna be using. And what you'll see with that is that we actually get really good performance from the Intel kind of in our base case, and it is actually a little bit better than the AMD performance. So we picked a target of like that 84-ish, 85 gigabits per second range. And if you're wondering why we picked a target of 84 gigabits per second, it's because we only needed 8 AMD EPYC Milan cores or 6 of the Intel Xeon cores to hit that 85 gigabits per second range, kind of doing this test, right? So the thing is, like, we had 128 threads in the system, and so frankly, we only had 100 gigabit Ethernet on the back. So well, that's really all we could really use, right? But when we transition to the hardware accelerator and we use that Intel QAT card, well, we got even better performance, because instead of using 8 cores on AMD or 6 cores on Intel Xeon, we were down to only 2 cores to be able to push 85 gigabits per second of IPsec VPN traffic. Now, for a big system, you may say, is that really important? But again, by having fewer cores that are working on just kind of pushing traffic around between systems, that means that you also get more performance that you can go and dedicate to VMs in that system, which gives you overall cost savings. That's why everybody loves this kind of stuff. Again, if you want to learn more about some of the optimizations and stuff that we're doing here, we're going to have links and GitHub links and stuff like that in the accompanying article. So again, go check that out. But frankly, a lot of the IPsec VPN vendors, appliance vendors, use Intel QAT. This is really why you can just get a ton of performance by using the offloads. Okay, for our third test, I think it's time we go look at nginx, but we're gonna do something a little bit different, and we're gonna look at the nginx HTTPS TLS handshake. And for this one, we're gonna use something called the Intel QAT Engine. Now, QAT Engine may sound like you automatically have the hardware accelerator, but you actually don't. We're going to be using 2 different things. We're going to be using the IPP backend, which is really taking advantage of all of the kind of software instructions that IPsec has. And we're going to be using that with QAT Engine. And that's basically what we're gonna call like our software solution. And that's the one that, you don't have a hardware accelerator in the loop, but you are using the Intel, extensions. But I also wanted to show you what that QAT accelerator would look like so we can use the QAT engine, but then have the hardware offload backend. Now, Intel actually had a diagram that I found on what this looks like from a TLS handshake and like which parts are getting accelerated by that. So I'm gonna put that here, but we're just gonna keep moving on, and we're gonna kind of show you those numbers instead of really kind of going through this in detail, because that would take probably like 20 minutes itself. So of course, pause if you need to. So for this, we also had to kind of come up with a target, because otherwise the numbers were gonna get really weird and we'd hit other issues in the system. So what we did was we picked a target of like 45,000 connections per second, and we did our absolute best to tune this and see how close we could get it to 45. Now, we didn't always hit 45,000 connections per second. Frankly, we tried like doing different, thread and core placements. We tried all kinds of different stuff. I mean, there's a huge multi-day effort to go figure out, what the optimal ones were. We were literally running different versions of it, even down to when I was recording the shots that I'm dubbing over. So here, it took about 100 threads without Intel QAT acceleration or any Intel QAT acceleration to do these 45,000-ish connections per second of HTTPS TLS with nginx handshakes. Now with the AMD EPYC Milan, where we only had AES and I to really work with on this, we were able to get this down to 82 threads that we needed to be able to run that 45-ish thousand connections per second range. So for the AMD side, you actually did use 18 fewer cores, but that's kind of like really kind of where we topped out, because we didn't have the functionality for the QAT engine. So by using IPP and the QAT engine, utilizing the new instructions that we saw in the Ice Lake cores, what we're able to do is go from that 100 cores down to 30 threads. Now by using IPP and the QAT engine, we were able to go from using 100 threads down to only 30. That is a massive savings just by using the proper software acceleration and using the hardware that's already in the cores. But we were not done there, because the next step was to use that QAT engine, but then to also take advantage of the hardware offload that we had in the QAT accelerator card. And by doing that, we were able to push our full around 45,000-ish connections per second using the QAT engine with the hardware offload and only 18 cores. So we took the actual number of thousands of connections per second and we put that over the number of threads that we had. This is what you can see in terms of the connections per second per thread. And really, this is a great example of why servers these days are so notoriously difficult to benchmark. nginx, HTTPS, TLS handshakes happen all the time. And if you're just doing a base case, you might say that the AMD EPYC platform is faster than the baseline Intel Xeon platform. And that would be a totally valid way to go look at it, I guess, if you're just kind of looking at the absolute baseline. However, if you're to go layer on the actual software that can take advantage of some of the new extensions and stuff that they have there, well then what you see is that the QAT engine means that you need 70% fewer threads without even going to the add-in hardware accelerators. But if you had the Intel QAT acceleration engine built into your server, well now you can get down to 18 cores, or a total of 72% fewer threads than we needed on our baseline case. And that's really why servers are so difficult these days, because not only do you have just kind of that baseline hardware, but there's so much going on with all the different vendors and all their software optimizations that, if you don't find these things, you can't take advantage of that kind of performance. And there are plenty of people that deploy these servers and don't take advantage of this extra performance that's just sitting there. The Intel QAT engine with the just kind of software offloads and IPP, that's something that you can go do on like cloud instances, and we've looked at that before in other pieces that we can link in the description. Now, there are some gotchas with QAT, and I really want to get to those because, frankly, the performance with the hardware acceleration is awesome, and it's very much similar to what we see in other places. But the first gotcha I really want to talk about is really just the fact that QAT is not static. We mentioned this earlier, but if you have an old processor, you probably don't have acceleration for some of the new, really, well-known ciphers. And for example, WireGuard uses Cha-Cha 20 Poly 1305, and that's the cipher that's like their bulk encryption cipher, and that works on like this QAT accelerator that we would be showing you here, but it doesn't necessarily get accelerated by older generations. So if you have like an Intel Atom C2000 series that's just sitting somewhere and you're trying to run WireGuard and accelerate it using QAT, it probably won't work because you don't have the proper cipher support. So to me, one challenge of it is just the fact that there are different versions of QAT, and while it's great that we keep getting new cipher support, if the cipher support isn't far enough ahead, you end up with endpoints that are going to be deployed and maybe deployed for a couple years more, and yet at the same time, they don't have the cipher that you need, and you don't realize that for another year or two after they're deployed, and like, that's a whole thing. And so I think that's one thing on QAT that is just the timing of the ciphers that it supports, I think is pretty important. Second is just the fact that QAT requires enablement. I mean, it's not like AES-NI where things just automatically take advantage of AES-NI. I mean, AES-NI or those type of extensions are absolutely everywhere, but QAT is still things where we are using, specific versions of software, and there were things, I mean, like I'll give you an example. We first tested the, OpenSSL, I think back in like 2016, and then we did IPsec VPN first time with QuickAssist back on the main site in 2017, I think. And back then, you were using CentOS, you were not using Ubuntu. There were very kind of strict things that you had to follow. And even before that, like OpenSSL didn't really support, or at least easily didn't support QAT acceleration. So, it's definitely one of those things that QAT still takes work. And because of that, I think that that's always going to limit folks. So I hopefully, as Intel rolls this out to more platforms and gets QAT adopted more widely, or at least available more widely, hopefully more software automatically takes advantage of it, because right now it's a lot better than it used to be. It's like we're using Ubuntu here, that's awesome. But also, I think there is more work that is needed, even though it may just be pulling something on GitHub, that work still has to happen. And then the third thing is just frankly, if you don't really do compression, decompression, or crypto encryption, decryption stuff, you might not actually use the QAT acceleration. And there are definitely cases on that. Like for example, maybe you have a render farm, or you're doing like some kind of CFD simulation where maybe you don't need that compression or encryption. And maybe in those cases, that's the case where, okay, this really doesn't help you that much. But I think that, a lot of things do communicate using, SSL and actually would use this. Compression has become very useful just for storing things on local disk as well as transferring stuff over the network. So I do think that overall, I think most servers will benefit from it, but there are cases where you just can't benefit from it. It's also an Intel solution, so it's not necessarily something that I expect to see AMD or ARM or somebody like that coming out with in the near future, unless Intel kind of changes their marketing on it quite a bit. And while I have talked about the caveats and some of the gotchas of this, I do want to just point out that if you are doing things like you have a storage array or storage array vendor, or you're running like an IPsec VPN appliance vendor, something like that, you totally understand QuickAssist at this point. Having someone go spend a couple days pulling stuff off of GitHub and getting it to work, I mean, that's not a huge thing if it's going to be a big part of your product. Really what I'm talking about is kind of the more mass market appeal. So overall, this is a project that took over 3 months to put together. So I want to say again, thank you to the Intel team and a lot of other folks that got together to make this thing happen. This takes a ton of effort to get going, but frankly, there's just not a lot on this in the industry, and I think there needs to be more of it because it is a big feature. It's out there, it's been out there for years, and yet nobody talks about it. I mean, we literally started looking at this in 2013 with Rangeley, and that's like almost a decade ago at this. But what I can definitely say is that the QAT hardware offload, I mean, that offers absolutely massive performance gains, and we showed that in all of the different scenarios we have here. So if you do use compression or encryption in your workloads, well, guess what? This might actually be something that you can use and get a lot of acceleration benefit for. Now, if you're going to use crazy ciphers and stuff that's not supported, you're not necessarily going to do as well. And it does depend on what kind of ciphers you're using, block sizes, all kinds of stuff. I mean, there's a ton of different variables here, but we can only show you a pretty limited set just because this took it just took a ton of time to be able to show you. Also, pretty much in all the tests, we showed how just using the software optimizations that are available, just pulling stuff off GitHub, will literally get you more performance, and not just a little bit more performance. I mean, you're talking about 50% or more performance, which is just awesome. So I totally think, if I had one thing to tell folks, I would say just start by going and finding these things, looking them up that are linked in the STH main site article, and go try them out because it's free performance just sitting there. And then I think the third thing I learned is that this is definitely going to be a major thrust of Intel going forward. This video was really looking at taking an accelerator card and putting this into a mainstream system. But of course, that's kind of a pain, right? You have to take an accelerator card and put it into a system and sell that. It would be much easier if you just had it built in. And well, the first version of that we're going to look at is really the Ice Lake D, which will be the next version of this, where you're going to see, how that works in the embedded space, because it's a little bit different than what we're showing here. But I think folks are just going to be wowed by that one as well. So we'll have that in a couple weeks. It's already filmed. We're just going to kind of separate those by a couple weeks to give people a little break. And also just looking forward to Sapphire Rapids, Intel's been putting like QAT on its slides about Sapphire Rapids, and I don't think, or at least I don't think you should take that as a coincidence that I'm doing this series, first taking a look at the acceleration card, then looking at it built in on Ice Lake D, and then Intel putting QAT acceleration on Sapphire Rapids slides. I would definitely read into that, like maybe, at STH, because we've been around for 13 plus years, we actually do things on multi-year timelines, and that's what we're going to be doing here. So this is why we're getting ahead of the story. And if you want to find out more about QAT, we are going to be having more resources on the STH main site about QAT in the near future. So we'll link those in the description. You can definitely go check those out. And if you did like this video, well, why don't you give it a like, click subscribe, and turn on those notifications so you can see whenever we come out with great new videos. As always, thanks for watching and have an awesome day.